Testing, testing, testing on the audio. Testing, testing, testing on the... All right. So looks like the audio is fine. Welcome everyone to AI4I Ask Me Anything Live as usual on our weekly Wednesday lunch session. I'm Ishan as usual, and welcome. As usual, we'll answer all your questions about AI4I Live. If we can't do it directly on the stream, just leave me your contact and I will send you the answers. All right. If you have any questions, just directly put them right into the YouTube chat, and we will get to your questions. Okay. If you haven't joined our Discord community yet, make sure you join our Discord community. Just go into you can use the QR code on your phone, scan the QR code right below me, and yeah, from there you should be able to join the Discord. We have a bunch of people talking about career, talking about career switches, talking about the industry, talking about news, all on AI and machine learning. So without further ado, let's get started. Right. Yes, here we go. So, from what we have left off last week, we did some programming of general programming, learning how to debug your problems, learning how to read error messages. We went through some data camp exercises. And this time it seems like we don't have any particular requests for any specific data camp exercise. So in that case, I'll just be continuing off where we left off last week. So in case you're just joining us, this is Statistical Thinking in Python, Part 2. I believe this is in your AI4I syllabus. So you go into AI4I, if you go into Statistical Thinking in Python, Part 2. It should be this one, Statistical Thinking in Python, Part 2. Yeah, this one. Yeah, so if you are here, lucky you. Most likely you won't be here, of course, because everyone here is at a different pace. The only thing in common that we all have here is that we're all AI4I learners. We're all AI4 industry learners. Okay, all the different batches are all here together. If you have any questions about certain concepts in Python or sklearn, pandas, just make sure you type it right in the chat. In the YouTube chat, if you're watching on our Discord, if you're watching on our forum, by the way, the Discord is like this. The Discord is like this. And our forum is Makerspace. Our forum is here at... That's our forum. No, not this one. Visit the site, please. Thank you. Give me a second. Thanks everyone for joining us today in your busy Wednesday afternoon. Wednesday lunchtime. Okay, so forum is just right here from Makerspace. This is where you access all of our courses, including AI for Everyone and AI for Industry. And our forum, you can also see the details for our AI4I AMA live sessions under community events here, community events, and click into here. And you can see all our sessions here. If you're watching from here, make sure you click into the title, which will bring you to YouTube. Just like that. It'll bring you in YouTube. And from there in YouTube, you can join the chat. From the chat, just say hi to everyone else in the chat together. And you can also ask your questions directly. We also have a Google form where you can ask questions, but I won't be checking it during the stream. So if you want to ask questions during the stream, make sure you ask them directly in the chat. Right. So without further ado, let's get started. We were halfway through Statistical Thinking in Python. If you if you aren't here, which obviously most likely you aren't, I highly recommend that at this time you can open up your own DataCamp account. You should have your own DataCamp premium access code, which is provided to you when you sign up for AI4I, and continue DataCamp exercises from wherever you stopped, whether it's the very first lesson or near to the end. Yep. And then as you do your DataCamp exercises, you can put me on in the background and I'll keep on talking in the background. If you have any questions, just let me know directly and I can help you immediately. If anybody has any specific requests for DataCamp exercises to go through, just put them down in the chat and we will get to that as well. If not, we're going to go into statistical thinking, parameter estimation by optimization. So parameter estimation. Okay, we'll look at what that is. Okay, so this is EDA. So again, this is the DataCamp. Hi everyone, I'm so sorry. Just got back from some technical difficulties. My computer crashed. Yeah, there's some memory error I've been having recently. So if it does happen again, on the off chance it does happen again, just make sure you, I'll get back within 5 minutes. So sorry about that. Okay, is the audio okay? Let me just make sure the audio is fine. The audio looks good. Okay, let's continue on. So this is EDA of literacy and fertility data. EDA is, of course, exploratory data analysis, I guess. Exploratory data analysis. So it's basically just looking into the data, finding out things about the data. This is DataCamp. On the left side, you see the exercise, the current exercise we're on. Bottom of that, we see the direct instructions of what they want you to do. Top right is the script that you should be editing or writing in order to complete the instructions. And the bottom right is the shell. You can play with the shell. It's basically a Python shell. You can type in stuff, Python code, and Python code will appear. Python code will run. So let's continue on. This is EDA. Next few exercises, we'll look at the correlation between female literacy and fertility. Okay, look at the correlation. So correlation is like when one goes up, does the other go up? And by how much does the other go up? Or does it go down when one goes up? Throughout the world, for ease of analysis and interpretation, we will work with the illiteracy rate. As usual, if you have any specific questions, just put them down in the chat. If you have specific exercises you want to go through, just put them down in the chat. Yes, it's not always a good idea it's always a good idea to do some EDA, of course, ahead of our analysis, because you need to get to know your data. So let's continue reading this finish first. To this end, plot the fertility versus illiteracy. So we have two variables here we want to plot against each other. So it's going to be x and y axis, two variables. Compute the Pearson correlation coefficient. Okay, this is just compute means just to calculate something, and I'm going to calculate the correlation coefficient. Yeah, so basically it's a number that describes how one variable changes against the other variable. The NumPy array illiteracy. So it tells, you can see that this illiteracy has a different format, a different text format. It's telling you that this is code, right? This is code, and actually this is a Python variable here. We have a Python variable here, so which means that if we type in the word illiteracy, we should get something here, and it says here is a NumPy, it's an array. I type in illiteracy, it says that this is array. It's a NumPy array. Yeah, an array is just a list of values. A list of values, right? It has It has the illiteracy rate among females for most of the world's nations. Okay, so this has illiteracy rates. The array fertility. So let's go for fertility. Has the corresponding fertility data. So this is the fertility data. Fertility data, blah blah blah. Fertility data. I believe fertility rate, if I'm not mistaken, is something like how many children are born for every 2 people. Is that right? How many children are born for every 2 people in the country? Something like that, I think. Let's Google that actually. What is fertility rate? It's always good to know what the numbers you're dealing with mean. Fertility rate. Okay. Is the average number of children that will be born to a woman over her lifetime. Okay. So only look at number of women and look at number of children that would be born to the women over her lifetime. Interesting. Not easy to directly calculate, but I guess we can just take these numbers at face value. The array fertility has the corresponding fertility data, sure. Here it may be useful to refer back to the function you wrote in the previous course to compute the Pearson correlation coefficient. Okay, let's click on this link and see what it says. Computing this in the previous course. Did I do this already? I can't remember doing this. It's okay. If we need to do that, then we will do that. Plot fertility on the y-axis versus illiteracy on the x-axis. Okay, so here we can put. Of course, here they don't tell us what the inputs are. So we will either have to know the inputs ourselves, or we have to take a hint here. No worries taking a hint. It's all for your learning. And some exercises, they are more demanding on you knowing the exact things to fill in. So no worries, just taking the hint. So we want to plot y-axis versus x-axis, fertility versus illiteracy. plt.plot. We're going to do, I can't remember which one is y-axis. Okay, so it should be fertility here and illiteracy on the first one, I believe. Copy and paste. Copy and paste. What equals to dot? Good question. Let's take a hint. The dot arguments should be the marker. Okay, sure. Marker equals to this. So the marker is what is the symbol that represents each point, each data point. So here the marker will be a dot. So it will be a dot marks each point. And you'll see that later. And here is line style equals to none. Means there's no line in between the data points. It's just going to be a scatter plot. What do I want to call it? What do I want to call it? Do they suggest what to call it? First arguments should be. Then I'll just call it scatter. plt.margins. plt.margins set the desired margin, 2% margin. So we can search this for ourselves. It's telling us to set a 2% margin. 2% margin, so we can Google this API and look for some help with the API, help with the syntax. Or we can use the help function here. In the shell itself, we can use the help function, plt.margins, and it says here, margins. Okay. So all input parameters must be floats. Floats are decimal numbers. Parameters are just inputs. So all inputs must be decimal numbers within the range 0 to 1. So here, I guess it should be 2% margin, so 0.02. This is my best guess. If it's not correct, then we will just edit it later, no worries. plt.x label percent illiterate, y label percent x, y, plt.show percent r. Based on this one, it takes in the first one and then the second one. So we'll do the first one, which is illiteracy, and the second one, which is fertility. Copy and paste. Looks okay. Then if we run the code, we get a plot here. It shows up the plot here. It says the percent illiterate, and if you actually run this code on your own Visual Studio Code, you will get exactly the same thing as well. Of course, it will be a different UI because it's not on DataCamp, but you will get the same thing if you run this on your computer as well. And if you guys haven't actually tried downloading Visual Studio Code or some other text editor to run your Python code, I strongly suggest you do, because I mean, you should get used to writing your own code and not just writing code on DataCamp exercises, right? Okay. Oh, let me just check the live chat. Anybody on live chat? Oh, nobody's saying on live chat yet. No, don't be shy. Just say hi, or just have any questions, just put them down right in the chat. Let me also just check the Discord to make sure that nobody has any pressing issues for me on the Discord. Discord. Yep. Okay, nothing seems to be urgent here. Great. Let's continue onwards. So I'm going to submit my answer, and it looks, oh, not perfect. Did you correctly specify the argument marker? Seems like it's okay. Consider using frozen instead. Running it generated an error. Marker. Line style equals to none. Consider using frozen instead. Oh, that's a bit strange. I'm not sure what is the problem here. Let's see, what could be the problem here? Print percent R, literacy and fertility. Literacy, fertility, marker equals to dot. Okay, let's do help on this first. Let's see whether we're doing something wrong. They're asking us to correctly specify the argument. Argument again means input, marker. Input name is marker. Input name is marker here. They're saying something is wrong with this. So okay, so this is how I debug in Python. We look at error messages. I look at this part of my code. I look at the part before my code. I look at the part after my code. Sometimes there's missing commas. This is a common source of errors as well. But here it looks like the comma here is fine, comma here is fine. Doesn't look like there's a problem there. So let's do plt.plot, and okay, let's check this. Character is point marker. Yes, that looks okay. So let me just look at this. I'm just going to look at this for a bit. If not, then I will just go ahead and get the answer. So it's marker equals to dot marker. Just now we saw marker, right? Marker is a marker style, yeah. So here, quarks stands for keyword arguments. The keyword inputs into the function. So all these are inputs that you don't have to put in. They are not compulsory, but you can put them in order to specify certain things about the function. So one of them is marker. So I'm going to scroll down and look for marker. Key arguments. Quarks is keyword arguments. So I'm going to look for marker again. It says marker style. Marker style is a type of input. It's telling you the type of input that it accepts. You can see here it says float, here it says color, blah blah blah. These are the types of inputs that it's expecting. So here it's expecting a marker style. So what exactly is a marker style? I have to scroll down more to find out. I'm going to scroll down more to markers. And it says here the character equals to this. So it looks like, it looks correct. It looks correct. So now I'm just going to show the answer. I don't want to spend too much time on this, so it's fine. Okay, marker equals to this. Line star equals to none. Let's see, what did we do wrong? Okay, let's copy and paste. I think it's because let's see. Is it because we called these X and Y? Let's just double check. Oh, right. I guess it's because we shouldn't have called these different variable names. These should have been X, these should all have been the same name. So this scatter, whoops. This variable, which is the plot that was returned, it should be the same name as this and this. In the solution, they called it underscore. It's because I guess they're not using the they're not using this variable, so they just call it underscore. I guess we should have just done that. All right, so we'll just press enter to continue, or just click continue. Again, if you're just joining us, this is AI4I Ask Me Anything Live, session number 8. Hope you guys are having a happy Wednesday. And if you have any questions, just put it down right into the live chat in YouTube. If not, if you have any specific data camp exercises you have problems with, just let me know, and we will go through them. If not, we are currently in the middle of Statistical Thinking in Python, Part 2. And we're doing some live coding, and you can follow along with me. Here, linear regression, we will assume that fertility is a linear function of the female illiteracy rate. So for those who have not been doing math for some time, it's trying to say that fertility changes linearly with illiteracy. So fertility equals to m times illiteracy. So this is the assumption, which means that when illiteracy goes up, fertility goes up by some constant amount, which is proportional to the illiteracy that went up. Yep. Okay. We can think of the intercept as the minimal fertility rate, probably somewhere between 1 and 2. Okay, the slope tells us how the fertility rate varies with illiteracy. Yeah, the slope tells us that we can find the best fit line using np.polyfit. Yes. Okay, plot the data and the best fit line. Print out the slope and intercept. Plot the data and the best fit line. So here, it's asking us to do a linear regression using np.polyfit. So let's do that. np.polyfit. np.polyfit for illiteracy and fertility. Of the regression line using np.polyfit. Remember, fertility is on the y-axis and illiteracy is on the x-axis. Okay, first thing I'm going to do is, for np.polyfit, I'm going to check the help. So I'm going to type help with the open parenthesis, open brackets, open curve brackets, and parenthesis. And then inside I'm going to paste in np.polyfit. Okay, so now it says here, how do I use this? I'm going to scroll up all the way. X and then Y. So it says illiteracy is on the x-axis. So I need to put illiteracy into x, which is the first one, the first input. To type in the second input, I type in a comma. type in the comma, and I can type in Y, which is the second input. Second input is fertility. Fertility. Print out the results to the screen. Okay. Print out the results to the screen. Slope equals to blah blah blah, A, B. Make theoretical line to plot. Okay, print out the slope and intercept, sure. To plot the best fit line, create an array X that consists of 0 and 100 using np.array. np.array, and then I'll put in 0 that consists of 0 and 100. Yeah, 0 and 100. So inside np.array, I happen to know the syntax for it, the API for it. So it's np.array creates an array. The array is just, again, it's just like a multiple values. So multiple values is item with multiple values, and inside the np.array function, we'll put in a list. So this list, this Python list, will be converted into a numpy.array. Alright, so that's 0 and 100. Then compute the theoretical values of y based on your regression parameters. So y equals to a times x plus b. Right, just exactly like what it says here. And then add the regression line to the plot. So I'm going to add x and y to the plot. So we're going to add x and y to the plot. X and then y to the plot. And draw the plot. It looks good. So let's run the code. Let's run the code. Oh no, it says polyfit dispatcher is missing. Again, right now we see an error. This is a good chance to learn how to fix the errors together. When you see an error, never be scared. Things you're interested in is which line is the error coming from. It's at least telling us line 8. So there's line 8, which is this one. So something is wrong with my polyfit. And then there is, line 8. This line 4 is in is somewhere else. So I don't look at this line 4. It's just line 8. For me, it's just line 8, which has a problem. It's np.polyfit. Again, probably my inputs for np.polyfit is not correct. So I can again do np.polyfit and just look for examples. So here, let's scroll up. Look for np.polyfit. Examples here. Here it says np.polyfit x, y, and then 3. So 3 is the 3 is the degrees, right? The degrees. Right. Of how many degrees? I believe it's only 1 degree, right? So we should just put 1 here. Comma 1. Run the code. Okay, and then we have a best fit line, which is drawn here. Okay, so we submit answer and check it out. Looks like it's right. All right. So this is how we can plot the scatter plot of fertility rates versus illiteracy rates, and then also draw the best fit line on the same plot in matplotlib. So you see this PLT, for those who are new to Python, again, as usual. PLT is what we import when we're importing matplotlib.pyplot. Matplotlib is a library inside Python. It's a bunch of code inside Python that we can use to draw graphs or draw plots. Yes. All right. So when we import it, we always call it PLT. So it will be something like import matplotlib.pyplot as plt. This is what we always do at the start. So it's already understood that it's done. Continue. How is it optimal? The function np.polyfit that you use to get your regression parameters find the optimal slope and intercept. It's optimizing the sum of the squares of the residuals, known as RSS, residual sum of squares. In this exercise, we will plot the function that is being optimized, the RSS, versus the slope parameter, A. So versus the slope gradient, how steep the slope is. To do this, we will fix the intercept to be what we found in the optimization, then plot the RSS versus the slope. Where is it minimal? Where is it minimal? Okay, if you're not sure about mathematics, you haven't done mathematics in a long time because you're, of course, working adult or whatever, just follow the instructions. You don't understand this, just follow the instructions and you can absorb it as you write the code itself. So here we go. Specify the values of the slope to compute the RSS, residual sum of squares. Okay, specify the slope to consider A values. Use np.linear space to get 200 points in the space between 0 and 0.1. So np.lin space. So again, I'm just going to do help to get the okay, I shouldn't have done that. I'm going to do help on np.lin space, help np.lin space. If you're not sure why this error was happening, is because I had the parenthesis here when I did help. Although np.linear space is a function, when you do help, you don't call the function. You're just finding out about the function, so you don't put the parenthesis there. The parenthesis, the curved brackets, is only there when you want to run the function. So we do help without the parenthesis. So start, stop, and then number, right? So start will be 0. Stop will be 0.1, get 200 points. How do I get these inputs? I need to look at the inputs in this function. This is the function, it's called linear space. And this is the function signature. It's telling us all the inputs that are expected. The first two inputs are compulsory inputs. They are mandatory inputs. If you don't put them in, you will get an error. Because you see, start and stop, they don't have an equals something. Equals something is the default value. It's the default value. So if you don't give any value for num or for endpoint, no problem, because they already have a default value. But if you don't give in any input for start and stop, then the function will throw you an error. And you can also see this error. So for example, let's see, I do np linspace 0. If I run the code, it'll give me an error. Here, linspace dispatcher missing 1. Again, when you see this error, don't be afraid. You can look at which line is having error. This is line 2, which is line 2, this one. Yep, we know this. We expected this to have an error. Then we look at the last line. Last line says type error. Type error. So there's a wrong type of information. To be honest, this in this case, right, in this specific scenario, type error is not very useful here. But the message is very useful. It says blah 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 is missing one required positional argument. Stop. Stop is the name of the argument which is missing. So stop is here. The second input, which is here. Start and then stop. The second input is missing. So it's expecting two inputs, but only the first one was given, which is why it's missing one required positional argument. So again, so we're going to do 200. Oh, sorry, not 200. 0.1 is where it stops. The start and the end It asks you for 200 points in between 0 and 0.1. So it starts from 0 and it stops at 0.1. And you want 200 points. Okay, 200 points. How do I know I can put 200 there? And what happens when I put 200 there? 200 here will translate down into num. The input, which is num, the third input. Yeah. So how many points we will have between 0 and 1, 0.1. Okay, so here there's a number of ways to put in 200. You can just put 200 here. Is the third argument here, the third input here, so it will directly be translated to the third input here, which is num. You can also specify it here to be num equals 200. No difference. Okay, so next, RSS equals to, we're going to initialize a sum of square of residuals. I'm going to use np.empty_like and the array we created above. Okay, so the array we created above is a values. Returns a new array with the same shape and type as a given array. Okay, so we're going to do that. RSS. Then for IA in enumerate a vals. Okay, so let me now go through what this whole thing means, this whole shebang means. Right. As I'm of course aware, as usual, there's lots of people here who are still new to Python, still new Python learners, and a lot of you guys I know are tuning in to our weekly live session for the first time as well. And some of you may not even have started the course. So I will go from the basics. Right. So here we do np.empty_like. Empty_like is a function here. We know it's a function because after the function there is a parenthesis here. Open bracket here. And then a close bracket here. Open bracket always comes with a close bracket. Inside is the input argument, which is a values. Okay. So now we have a for loop. We have a for loop here. This is a for loop. Okay, for loop. What is a for loop? A for loop is a type of a loop. It's a loop, which is a way to run a line of code many times. It is a way to run a line of code many times. So what line of code are we running many times? This is the line of code we're running many times. This is the code that is inside the for loop. Inside the for loop. This is the for loop. This code is inside the for loop. We'll run this many times. How many times will we run this? We're going to run this n number of times, where n is the number of items inside a vals. So how many items are inside a vals? What is this a vals? A vals is a vals is an array. A vals is an array is the name of an array, name of a variable, which is an array. Here, right? And what value was here? We put the value in here at the start. np.linear space 0 to 0.1, which means we're going to put in numbers from 0 to 0.1, which are evenly spaced out. Evenly spaced out. So how many items are there in this np.linear space 0 to 0.1? Num equals 200. For those who are following along, you should be answering 200. Put num equals 200. Number, there's 200 numbers inside this array. 200 numbers inside this array we'll put into this a values, and we have this a values here. So we're going to loop over this. We're going to run this 200 times. One time for each item inside a values. 200 times. And 200 times, and now each time that we run this code, we will refer to the items inside a values as I and a. The first time it will be using I, which will be 0. The I will keep going up and up. It will keep incrementing. It will be +1, then +1 again. So 0, 1, 2, 3, 4, 5, 6, all the way up to 199. 200 times, right? 0 to 199. So that's what enumerate does. Enumerate. So let's give you an example. So let's say x equals to 5, 10, 15. So if I do for I a in enumerate enumerate x. Okay, of course I should do shift enter. You shift enter so you can type in the second line of your for loop. Then you do print I and A. Okay, I do that. You can see something interesting now. Print I comma A. So each line is showing me I and then A. So it's looped 3 times. You can see that this is the code that's inside the for loop. It's run 3 times. It's run 3 times because there are 3 items inside X. First item is 5, second item is 10, the item is 15. So we run it 3 times. The first time, I will be 0, A will be 5, which corresponds to the first number in the X. Inside this thing that we are looping over. We're looping over enumerate X. Okay, it gives us 0 and 5. Second number we have is 1 and 10. Second time we have inside enumerate X is 1 and 10. In fact, if you just type enumerate X and you print enumerate X, I can't print it, right? Because it's a generator, right? Can I do print enumerate X dot next? No. How do I get the first? Okay. Okay. Never mind. Okay, so but anyway, here you can see that when we loop over enumerate X, we loop over it 3 times. The first time IA is 0 and 5, second time IA is 1 and 10, third time IA is 2 and 15. So I comes from the number of the loop, number of the items inside the list X. A comes from the item itself, the item itself inside list X. Inside list X we have 5, 10, 15. First time is 5, second time is 10, third time is 15. And that's how we get, that's what happens when we do for IA in enumerate A underscore values. Okay, I know this is going to be definitely complicated. If you don't understand, no worries. Just try and listen and then try and understand. And then you can repeat what I just said 30 times. Right? You can just go back and watch it again 30 times. You can press J, I think, on your keyboard in YouTube to go back 10 seconds. Increase the speed of the recording, and just keep listening to the explanation. Keep trying out for yourself. Try out different things, and you can eventually understand what is going on exactly here. So here it says write a for loop to compute the sum of RSS of the slope. The RSS is given by np.sum, so we can do np.sum, np.sum. So it is a way to sum a bunch of inputs. Sum all the inputs. There's np.sum, right? np.sum. So np.sum, we can just follow this one. Y data minus a times x data times to the power of 2. Okay, so it's going to be a fertility is the y data. So fertility is y data, so we just type in fertility here. And here is illiteracy. You can see here is fertility is the y data, literacy is the x data. Alright, plot the RSS versus the slope. Okay, plot RSS versus the slope. RSS versus the slope. A underscore vals, and we actually have this. Looks okay. I run the code, and we see something like this. Sum of squares of residuals. Answer the answer. Right, no, I don't think I passed it in the correct order, so it should be avals and then RSS. No, that's not right either. Let's see. Oh, of course, it just wasn't showing up properly. This wasn't showing up properly. Right, so you just plot against avals against RSS against the avals. You just put it like that. Right, just follow. Yes. So on the y-axis here, we can see the sum of squares of residuals, and the x-axis here, we can see the slope. Right, you can see the slope. Importance of EDA. Anscombe's
In 1973.
Okay, we'll just skip through this for now. Why should exploratory data analysis be the first step in the data analysis of data? After getting your data imported and clean, of course, you can be protected from misinterpretation of the type demonstrated by Anscombe's quartet. EDA provides a good starting point for planning the rest of your analysis, yes. The EDA is not really any more difficult than the rest of the subsequent analysis, so there's no excuse for not exploring the data. All of these reasons. Always do EDA, yeah? Linear regression on appropriate Anscombe data. Okay, so for practice, perform a linear regression on the dataset from Anscombe's quartet that is the most reasonably interpreted with linear regression. Okay, so let's just follow in here. Statistical thinking in Python. We'll do compute the parameters for the slope and intercept using np.polyfit. Again, same thing, np.polyfit. We will do x and y, and I believe linear regression, we're going to put the degrees as 1 because it's a linear regression. Print the slope and intercept. So print the slope and intercept. So A and B. Here, x theoretical and y theoretical. We want to generate it from the linear regression. So the linear regression is here. Your x array, which you can create with np.array, should consist of 3 and 15. So 3 and 15. To generate y data, you just multiply the slope by x theory. So A times x theory plus B, which is the intercept. Plot the Anscombe data and the theoretical line. So we want to do plt.plot the Anscombe data and the theoretical line. So x theory and y theory. And the theoretical line. The theoretical line and the Anscombe data is in x and y. So again, we're going to just do this, copy and paste it. And here I'm going to put x and then y. So this one will be the Anscombe data. This is the theoretical line. X label, y label. Sure, all looks like it's done already. Right, let's submit answer. Looks completely wrong here. Expected x theory on the first one. Okay, expected x theory on the first one. Did you specify argument of marker? No, I did not. Marker equals to dot line style equals to none. Let's do the... Yep, so this looks okay. Plot, so it asks us to, right, of course here it says, remember to include marker equals to dot and line style equals to none keywords. And none here should not be the actual Python none, it should be the string, lowercase none. Okay. So here we're gonna plot Anscombe data as a scatter plot. And the theoretical arguments, we don't need this because we're gonna plot the line. Course, so then we're gonna run code and cool. Now we can see this is the actual data here, the little dots here, and the best fit line again here is the orange line here. For those who are just joining us, thanks for joining us on this Wednesday lunchtime afternoon. Hope you guys are having a happy Wednesday. And we are going through statistical thinking in Python, one of the more intensive mathematical courses on data camp, which is part of AI for industry. Okay, so now we have another exercise here. Linear regression on all Anscombe data. Now to verify, all four of the Anscombe data sets have the same slope and intercept from a linear regression. You'll compute the slope and intercept for each set. Okay. For each one in the sets Anscombe X, Anscombe Y. So this is what zip does. Zip is a way to let's how do I give you an example? Let me give you an example using Google Sheets. Okay, so let's say you have you have two lists. The first list is like this: 1, 3, 5, 7, 9. This is the first list. Okay, this is the first list. This one. Then you have a second list, which is list 2. Okay, list 2. And second list is 10, 20, 30, 40, 50. This is your first list of items. There's 5 items inside. Second list of items, there's 5 items inside. When you do a zip list 1 and list 2. So sorry, there seems to be a plane flying overhead. Let me just mute the microphone. Alright, looks like the plane is mostly gone. So when you zip list 1 and list 2, what you get is 1. Oh, the plane is back. Alright, looks like it's a bit better now. Okay, so when you zip list 1 and list 2, you get the two numbers side by side. The first number of each list side by side. You get something like this. Okay. You'll get something like this. And you get them side by side. Of course, side by side is a very layman term, right? In Python, you actually get a new list of 1, 10, 3, 20, 5, 30, 7, 40, and 9, 50. This is what you get when you zip these two lists together. Okay, these two lists, you zip them together, you put the same numbers, the first numbers you put them together, second numbers you put them together, third numbers you put them together. Just like that. Yep. Okay, so we continue on. So in this way, when we zip Anscombe X and Anscombe Y together, you'll get x and then y, x and y, x and y, x and y. Yeah. Then we can loop over that, and for each x and y, we will do something. We will do what? Compute the slope and intercept. How did we do that just now? We did, if I go back, we did np.polyfit. np.polyfit. So we go next exercise, np.polyfit. Just like that. np.polyfit 1, and then that's okay. Looks good. Great. And from here you can see the slopes and intercepts are the same, or approximately the same. So now we're going to continue on. Generating bootstrap replicates. Oh no, this guy's going to start talking. I'm going to skip him over. Getting the terminology down. Okay. So, getting tripped up over terminology is a common cause of frustration in students. Unfortunately, you'll often read and hear other data scientists using different terminology for bootstrap samples and replicates. This is even more reason why we need to be clear and consistent for the course. So before going forward discussing bootstrapping, let's get our terminology down. If we have a dataset with n repeated measurements, a bootstrap sample is an array of length n that was drawn from the original data with replacement. Okay, this array is a group of items. So dataset with n repeated measurements is an array of length n that was drawn from the original data with replacement. So basically, you draw n samples with replacement. Right. Yeah, with replacement. So you draw the samples already, then after that, you put them back and then you draw samples again. Yes. Okay. What is a bootstrap replicate? This is another name of bootstrap sample. It's in a single value, actual repeat of the measurements. To be honest, I'm not very clear. I'm just going to submit the answer and see. Actual repeat of the message on a single value of a statistic computed from a bootstrap sample. I haven't gone through this in a while already. So a bootstrap replicate is a single value of a statistic computed from a bootstrap sample. Okay, I'm sure we'll get a clearer idea as we go on through this. Bootstrapping by hand. To help you gain intuition about how bootstrapping works, I do understand that some parts of this is quite mathematically intensive, but no worries. It gets better later on. It definitely gets better later on. So just stick with it, even if you don't understand exactly what some parts mean. Yeah. If you find yourself getting burned out, no worries. You can just skip and continue with the next course. Continue with the next course or next topic. To help you gain intuition, yeah, because this is more of understanding the concepts which are related, but not directly on machine learning itself. Yeah. So to help you gain intuition about how bootstrapping works, imagine you have a dataset that has only 3 data points, -1, 0, and 1. How many unique bootstrap samples can be drawn? Okay, how many unique bootstrap samples can be drawn? What is the maximum mean you can get from a bootstrap sample? It might be useful to jot down the samples on a piece of paper. These are too few data to get meaningful results from bootstrap procedures, but this example is useful for intuition. Okay, how many unique samples can be drawn? I believe the answer is 10 unique samples, maximum mean is 1. No. Absolutely not. Maximum mean should be 1. One of them, right, has a mean of 1. Okay, Okay, so again, so now I have gotten a refresher as well. So let me explain my understanding to you guys based on my refresher. So, so here we have 3 points here, -1, 0 and 1, right? So we have -1, 0 and 1, -1, 0 and 1. You have 3 items. Every item in a Python list is separated by a comma, right? 3 items. So when we want to have a bootstrap sample, we draw them with replacement. So the first, and it's going to be the same length as the original list itself. This original list has 3 items. We're going to have 3 items on our side. So 3 numbers, we're going to draw them, and we're going to replace them. So we can draw the same number any number of times. So we can do this. We can do this, and then like that. We can do all of this, right? We can do 1 on 1 as well. So how many unique samples are there? So the number of unique samples would be 3 to the power of 3, right? Which is 27. Why is it 3 to the power of 3? Because the first number can be can have 3 different values, -1, 0, or 1. Second number have 3 different values, -1, 0, or 1. Third value also same. So it's 3 times 3 times 3. 27. Maximum mean is 1. Mean means average. It doesn't mean how mean your sister is to you. So the maximum mean is 1 because you can have 1 on 1, in which case the mean is 1. I'll submit answer here. Oh wait, sorry. What's this one? For underscore in range 50, so here again you can see the for loop, which is very important in Python in general. The for loop here is telling us that, hey, we're going to do this, we're going to run this code many times. How many times are we going to run this code? We're going to run this code 50 times. We're going to run this code 50 times. How do I see it's 50 times? 50 is the number of items inside this iterable, this thing that we are looping over. Again, if you're new to Python, you have to be familiar with this term, looping over. So we're going to loop over this this item, this list-like object. Okay, we're going to count the number of things, number of elements inside this list-like object, and run this code 1 time for every item inside this. What is this item? This item is a range item. What is a range item actually? So range 5, it just tells you range 0 to 5. But so you need to actually turn it into a list. Oh, sorry, didn't have the extra close bracket. If you do a list range 5, you can actually see what this range is. It's a list-like object that starts from 0 and goes all the way up to 5, but doesn't include 5. Another airplane. Okay, looks like it's mostly gone. Alright, yeah, so this is range 50. So there's 50 items inside this iterable. This thing you can iterate over, you can loop over. So we're going to run this 50 times. Okay, continue. DS sample, we're going to generate a bootstrap sample. Okay, 50 bootstrap samples of the rainfall data and plot their ECDF. Okay, so if you want to know what's ECDF, you can always just Google it. ECDF, which is a empirical cumulative distribution function. So as you move to the right in the X value, you accumulate your Y values. So you always start from 0 and go up to 1. Okay, so here, write a for loop. So we're going to do random.choice to generate a. So I'm just following the instructions here. In this exercise, we're going to generate random bootstrap samples from the set of annual rainfall data measured at the Sheffield weather station. For those who have just joined us in this session, this is AI4I Ask Me Anything Live, session number 8. My name is Ishan and I'm from AI Singapore. If you have any questions, put them right into the chat in YouTube. If you're watching from Discord, watching from the forum, just click in and make sure you watch on YouTube so you can say hi to the rest of the learners. Yes, if you have any particular questions you have, just put them right into the chat. Do not put them into the Google form and do not check the Google form during the session. I can see your chat if you type it. Okay, great. And if you have any particular data chem exercise you want me to go through, just let me know. If you have any Python concepts you want me to go through, just let me know. BS_sample, random.choice. So random.choice, rainfall, size equals to land rainfall. Okay. So the data is stored in this array in units of millimeters. So actually, let's look at the array itself. Rainfall. If I type rainfall, it shows me it's an array. So this is an array. It's like a list. Okay, it's like a list, and this is how many millimeters of rainfall there is from this year up to this year. So we can look at the amount of rainfall each year. Okay. So rainfall. So np.random.choice, what does this do? Let me give you an example. So random.choice, this one is something I actually know offhand. So it's rainfall. So again, contrary to popular belief, people who write code, people who are writing code for a living, they don't memorize every single function that they need to know. They just look it up when they need to write it. Right, so here, np.random.choice, but there are some API that they know offhand. So np.random.choice, it gives us one random choice from an iterable, from an item with many objects inside. It will pick out one item and give it to you and return it. So it returns you one item from this. Okay, so if I do it again, of course, we expect it to be a different item, just like that. And here, size means how many items you want to pick out. So if I do 2, comma size equals to 2, it'll give me 2 different items from this rainfall. So size equals to land rainfall, which means we're gonna get a new bootstrap sample, which is the exact same number of items as the array itself, as the array rainfall itself. Use the function ECDF that you wrote in the prequel to this course to generate the X and Y values for the ECDF of the bootstrap sample. Yes. Generate the X and Y. Yep. For BS sample. Then we want to plot this X against Y. Marker equals to dot and line style equals to none. This means it will be a scatter plot. And here, what equals to gray? What equals to gray? What do they want me to? Oh, color equals to gray. Specify color equals to gray, and alpha equals to 0.1. So color is the color of the marker, I believe, and alpha equals to 0.1 is the transparency. What is the transparency value? So 1 is that it's not transparent at all. 0.1 means it's very transparent. Very transparent. And we're going to plot this. We're going to plot this from the original data. Compute and plot ECDF from original data. So we're going to do ECDF from the original data, which is rainfall. Then we're going to plot X and Y. with the marker equals to dot. Alright, and then looks like this looks good. If I run this, let's see what happens. Great. So the blue line here, this blue line shows us the ECDF. Again, ECDF is the empirical cumulative distribution function. So it accumulates the data, accumulates the values in the data from 0 to 1, accumulates the value in the data along the blue line, right, along this blue line. And then we can see all these ups and downs. This is the distribution of the bootstrap values. Yeah, the ECDF of the bootstrap values. Yeah, the bootstrap value possible ECDFs. Right. So let's submit our answer. Looks good. Okay, bootstrap confidence intervals. So we're going to generate multiple bootstrap replicates here. Okay, the function bootstrap replicate underscore 1D from the video is available in your namespace. Let me see if I can play the video and have the audio be okay. It should be okay. Let me just reload this page. Please load, please load. Just now it was loading, but now it doesn't want to load. I'll just refresh it again. No big deal. If it doesn't load, then we will just continue on. No worries. I think it's not loading. Let's continue on. The function from the video is available in your namespace. So let's check it out. We can do bootstrap underscore replicate underscore 1D. We can do help for this. It's a function that is just so here you can see that when we do help, there's actually not much help. There's not much help. It just shows us what are the inputs that is expected. There's data, then there's function. It expects two inputs. The data first, which is probably a NumPy array, and then a function. Right. So this is a function that's written by someone. It's not a function from a library. Okay, so now we're going to write another function, draw BS reps. Okay, so how do you write a function? Very, very important part of Python as usual, writing functions. In fact, when I teach Python, I always believe that the most important thing you need to learn in Python is to be able to write your own functions. Okay, if you can write a function, you can get an internship. That's why I always tell people. Yes, so draw BS reps, BS replicates. BS underscore replicates equals to np.empty. So I'm just reading the instructions here. We want to use np.empty, right? So I know that I need to use this function np.empty. It is telling me how many. It is going to generate an array with empty objects, an empty array, with some amount of size, right? With some number of objects inside, but it's going to be all like NA values. Okay. So we're going to call it this of size equals to size. Size equals to size. Yes, okay, looks good. For I in BS replicates, I guess. So we're gonna loop over BS replicates. No, that write a for loop that ranges over size. Okay, ranges over size. I guess that's what that's telling me is I want to do this for each I want to loop size number of times. Basically, I want to loop size number of times. When you want to loop size number of times, what you got to do is always do range size. So, for example, if I do for in range 5, shift enter, print hello world, it will print hello world 5 times. If I want to do something 5 times, I always do for whatever in range 5. Okay. It's okay if you are new and you don't understand 80% of what I'm talking about. If you just understand 20%, then and you keep working at it, then you play the video, replay the video, try and keep grokking more and more. Take a break, come back, try again. You will get it eventually. Yeah, just don't give up. Very, very important. As most of you know as well, I am also not a programmer by education. I was starting in accounting and business, and then I took up programming myself. So if I can do it, you guys can do it too. Right. So BS replicates I equals to bootstrap replicate 1D. It tells us write a for loop that ranges over size, computes a replicate using bootstrap replicate 1D. To see the function signature of bootstrap replicate 1D. What's a function signature? Again here, it is telling you what inputs does it expect. To be honest, normally a function signature also tells you what is the return value. But I believe a function signature always tells you what is return value. Signature. You can just Google function signature. Yeah, see, it defines the input and the output value, you see. It just tells you the inputs and the outputs. Inputs are always the parameters, the arguments. You, as a new learner, you can treat parameters and arguments as the same thing. They're all inputs. When I say output, it also means the same thing as a return value. Same thing, return value. See, return value. But here it doesn't say what's the output. So actually, I believe it means there's no output. No, but actually there is an output. Which, yeah, clearly there is an output. But never mind. Here, we'll just say the function signature is like this, which is it takes in data and func. So we'll just put in data and func. Func here, of course, stands for function, which is passed in from draw BS reps. For those who are new to Python programming, what's happening here is we are creating a new function. This function here is called Mr. Draw underscore BS underscore reps. That's his name. Draw BS reps. When we create this function from the ground up, from mud, from dirt, from earth, we create a brand new function. And this brand new function, we teach him to accept inputs from whoever wants him to do work. When you want this Mr. Draw BS reps to do work, you have to give him inputs. Okay, before he can do his work. What inputs you have to give him? You need to give him your first input, which is called data. Second input, which is, he will call it func, which is the function. And then he will do his work using data and function. And he will do whatever function you tell him to do. And he'll run this bootstrap replicate 1D using the data and function that you give him. All right. And then after that, at the end of all of his work, what he's going to do is he's going to create this value and fill up this value, BS underscore replicates. And he's going to give it back to you. He's going to return this value to you. He's going to give back this value to you. He's going to give back this value to you. Submit answer. We're golden. BS replicates of the mean and the SEM. Okay. SEM here is standard error of the mean. Okay, so now it's a bit longer here. I'll just read through the whole thing. So the bootstrap replicates. I'm gonna go back one time. Let's see if I can actually play this video now. That would be nice if the video would actually load. Would be very, very nice and very, very timely. Cost no such luck. No such luck. No such luck. That's alright, no worries. You can watch it on yourself. Yes, we'll just continue on with the exercises. Now this is bootstrap replicates of the mean and the SEM. In this exercise, you'll compute a bootstrap estimate of the probability density function of the mean annual rainfall at the Sheffield weather station. Remember, we are estimating the mean annual rainfall we would get if the Sheffield weather station could repeat all of the measurements over and over again. This is a probabilistic estimate of the mean, which means that it will come with probabilities, correct? The percentage chances of each outcome. You will plot the PDF as a histogram, and you will see that it is normal. Okay, the PDF is the probability distribution function, which is how the values are distributed. And you see that it's normal, which means that it has a bell-shaped curve. Okay, bell-shaped curve. In fact, it can be shown theoretically that under not too restrictive conditions, the value of the mean will always be normally distributed. This does not hold in general, just for the mean and a few other statistics. The standard deviation of this distribution, called the standard error of the mean, or SEM, will be given by the standard deviation of the data divided by the square root of the number of data points. Okay? You just take this as at face value and just follow. I.e. for a data set, this is the SEM, the standard error of the mean. Using hacker statistics, you can get this same result without the need to derive it, but you will verify this result from the bootstrap replicates. Okay, so here now we have the dataset has been preloaded for you into an array called rainfall. So again, we can go rainfall, and we can look at the dataset here. It's just a value of numbers which are representing milliliters of rain in this area. Draw 10,000 bootstrap replicates of the mean annual rainfall using your draw BS reps. So I'm going to do draw BS reps. I'm going to call the function I created last exercise I created Mr. Draw BS reps. So now I'm going to call on him, Mr. Draw BS reps. Hey, please do your work. I'm going to pass you in your data that you want, your inputs that you need. First input you need is data, which will be rainfall. Then the function will be np.mean, as you can see here. Pass in np.mean as the func. And the size will be 10,000. Right, size 10,000. You can also put size equals 10,000, or just leave it like that, 10,000. Same thing. SEM equals to, just follow this here. Compute and print the SEM of rainfall. So you just follow the formula here. It says np.std, which is the standard deviation of data. Data here is rainfall, and square root length of the data. Length of rainfall. Len gives you the length of the object, which is how many items are inside this object. So rainfall is like this. So if you do len rainfall, it gives us 133, which means there's 133 numbers inside this. 133 items inside this array. Okay, 133 items. If I have a list like this, which is an empty list, if I do len x, it gives me 0. There's no items inside the array. 1, 2, 3. If I do len x, it gives me, oh sorry, if I do x equals to 1, 2, 3, and I do left X, of course it will give me 3. There's 3 items inside the array. BS, which is bootstrap, standard deviation, compute and print the standard deviation np.std of BS replicates. And then make a histogram of the results. Make a histogram of the results. Normed is true and bins equals to 50. The results would be BS std, and we run the code and see what happens. Doesn't look quite right. Did I miss out something? No, should we be running BS replicates? No, I think we're supposed to make a histogram of the mean, the standard error of the mean, right? So I think we're supposed to do plot histogram of the SEM here. SEM here, we will run code. Great, that doesn't look right as well. Okay, let's just submit the answer and see what's wrong. Did you correctly specify the first argument? Definitely not. I did not specify the first argument correctly. Expected something different. Expecting the bs.std. Nope, not the bs.std. Looking for the bootstrap replicates. Are you looking for the bootstrap replicates? Yes. So just now I did run this, but it wasn't showing up properly, which got me confused. So when we do run the bootstrap replicates, we see that the probability distribution functions show what the mean annual rainfall could probabilistically be. So most often it's something around 800 milliliters of rainfall, which means that if you let it rain for the one whole year, you will see 80 cm of rain stacking up. 80 cm of rain stacking up from the ground. Press enter to continue. Confidence intervals of rainfall data. So a confidence interval gives upper and lower bounds of the range of parameter values you might expect to see if we repeat our measurements. So yes, for example, like how confident are you? What's the percentage that the value would be within a certain range? That's why we're talking about confidence intervals. For named distributions, you can compute them analytically or look them up. One of the beautiful properties of the bootstrap method is that you can take percentiles of your bootstrap replicates to get your confidence interval. Conveniently, you can use np.percentile function. Use the bootstrap replicate you just generated to compute 95% confidence interval. So that is, give the 22.5th percentile and 97.5th percentile of your bootstrap replicates stored in bootstrap replicate. So we do np percentile. We can find these two percentiles, right? Percentile 0.025. Let's do that. Q. Of course, we need Q, which is in fact, let's do help first. Let's do help for np.percentile. Scroll all the way up to find the function signature to see what we expect. A and Q. A will be the array. Q is the percentile to compute. So we need first the array, the second is the percentile to compute. So first one will be the array, np.percentile. Array is called BS replicates. percentage compute 0.025. Right. So this is the 2.5th percentile. If we want to do 97.5, 97.5 is like this. Should be that. And then what is the 95% confidence interval? What is the 95% confidence interval? 95% confidence interval. Great. So here, let's do. Am I missing out something here? I think it should be 97.5, right? Yeah, I definitely messed that up. So if you want 2.5%, it should be 2.5% like this. And 97.5, it should be 97.5. I'm pretty sure. Yeah, 0 to 100 inclusive. So it's 0 to 100. Not 0 to 1. Okay, so now this is the percentile. 95% confidence interval. (95% confidence interval). To be honest, now I'm a bit confused. But we will try and see what is the hints that they're giving us. Remember, when you pass the percentile, yep, is 2.5, yes. That's the instructions. Let's take another hint. Right, you need to pass in both. Okay, right, you need to pass in both values as a list. So here we need to pass in the full list, which will give us this, which is what we got just now, actually. It's what we got just now. Do the same for BS replicates. That's what we got just now. Oh, right. I'm a bit confused now. What is the 95% confidence interval? Shouldn't the interval be a range? Okay. Yeah, but this is the only value within the range. So this value is within the range in the 95% confidence interval. So yeah, I guess they put this at the right answer. So just submit answer and continue on. Sometimes the exercises aren't perfect, which is a pity, but we don't unfortunately have direct control over all the exercises. Yeah, we intend to continue to make adjustments to the course directly in Makerspace so that you can do more useful learning and yeah, more understandable learning during your course, right? Even if the DataCamp exercises may not be perfect. We also highly recommend you to look for other resources outside of DataCamp. It's just one of the recommended resources. Bootstrap replicates of other statistics. Okay. Here we have draw 10,000 bootstrap replicates again. So we're going to do draw BS reps. Stored in rainfall. Data is rainfall. Function is np.var, which is the variance. Size is 10,000. Put the variance in units of square centimeters. So the variance will be BS replicates equals to BS replicates divided by 100. I think that looks about right. PL plot matplotlib histogram BS replicates and norm equals to true and bins equals to 50. Run the code and looks about right. Right. So here, what's happening here? We actually did, we drew BS replicates, bootstrap replicates, 10,000 of them, and saved them into BS replicates. So you see BS replicates here is now going to be a NumPy array, type of BS replicates. It's a NumPy n-dimensional array. So we look at BS replicates. Yeah, so we get an array here. And then if we divide it by 100, what happens is it will divide each value by 100. It divides each value by 100. So we get from square millimeters down to square centimeters. Square centimeters. Then we plot a histogram. The histogram shows the distribution of the values. And when we talk about bins, which means that we're going to put them into groups. Yeah, we're going to put them into groups, a fixed number of groups, 50 different groups. Yeah. So that you have a histogram with some shape, right? Histogram with some shape. Normed is true, and yes, so we have this. Submit answer. Let's continue on. Right. For those who are just joining us, welcome again to AI4I AMA Live. Thanks for tuning in. If you have any questions, this is where you can ask all your questions on Python, on the content in AI4I. Yeah, and you can feel free to say hi to your fellow learners in AI4 industry. Make sure you join the Discord. The link is in the QR code. You just scan it above, right above me. Is it this way? This way, yeah. So this way you can see the Discord link. Discord link, you should also be able to find it in the description of this stream. Yeah, this is where we discuss a lot of things, ask a lot of questions. Really good place for you to connect with industry mentors as well. Yes. So here now we have BS replicates. Generate again 10,000. So draw BS replicates. Data is no hitter times. So the modern era of baseball. Okay, we're gonna talk about baseball, and no hitters means I believe they have no hits, right? They have no hits within the game. No hitter times, and then the function will be the mean of the data, np.mean. np.mean, and then 10,000. Confidence interval, np.percentile, and this is from BS replicates. And I know this only because it was just in the previous exercises, so we want to put this 2.5 to 97.5. Print the confidence intervals. Print this conf interval. Games. Okay. All right. Looks about right. Check it out. We run that. Yes. So this is the number of games of no hitters. Right. So report a 95% confidence interval. Yep. Looks good. This has been done for you. Plot histogram. Yes. Submit answer. What the typical time between no hitters is? It could be anywhere between 660 to 870 games. These are the games. So now you can let me explain this a little bit better. So the no hitters are games where there's absolutely no hits in baseball. So baseball, you throw from the pitcher to the catcher, And if the batter can hit the ball and run to and get at least one base, run to at least one base, that's a hit. If there's no hits, that's a no-hitter. So there's a time between no-hitter games. So it's on average around here, 660 to 871 games. Pairs bootstrap.
When we
Oh, actually, let me go back. It's actually working, so let's just. The server failed. I really can watch it once. Not ideal. Let's see, does it load? Well, the first time it loads, the second time it doesn't load. If you guys have been having the same problem, do let me know. We'll try and find some solution for this. If not, I'll just continue on. A function to do pairs bootstrap. As discussed in this video, pairs bootstrap involves resampling pairs of data. Each collection of pairs fit with the line, in this case using np.polyfit. So we're going to do pairs bootstrapping. Right? Just now we are doing bootstrapping for one data set. Now we're going to do bootstrapping for pairs, right? Pairs of data. Okay, first we're going to write the function again. When you write the function, we're creating Mr. Draw BS pairs linear regression. LIN is linear, REG is regression. Okay, and then XY is the names of the inputs that we expect. We're going to expect X and Y. And another optional input, which is size. Okay, and at the end of the day, Mr. Draw BS pairs linear regression will return two outputs to the user. It will return first output, which is BS slope replicates and BS intercept replicates. BS slope replicates and BS intercept replicates. Okay, so the first array of indices to sample from is going to be set an array of indices to sample from. np.arange, right? np.arange. So np.arange, let me just show you guys what it does. So np.arange from 5 to 10, it creates a range from 5 up to 10, but not including 10. So now we're going to write create an array of indices going from 0 to len x. I believe from 0 you don't need to put anything here. So here you just put len x. So then it looks about right. Len is the length of the size of this x, size of the input, which is how many items are there inside this input. How many items are there? Initialize the replicates. So initialize the replicates, we're going to do np.empty. The size will be size. And same, this will also be 0. And then we're going to generate the replicates. Okay, so to generate replicates, we're going to do random.choice from the dataset. The dataset is going to be random.choice x, y. We sample the indices ind. Okay, right. Indices is here, ind is size equals to size, I believe. Size equals to size, I believe. Make new x and y arrays, bsx and bsy, using the resample indices. Indices is just a multiple of index. Bs indices. Using the resample indices. To do this, slice x and y with bs indices. Check bs indices. We'll slice it with bs indices. Alright. And then now we do BS slope replicates I and BS intercept replicates I equals to NP polyfit on the new X and Y arrays. X and Y, and then degrees will be 1. Degrees will be 1. Return the pair bootstrap replicates. And this, yes, return the pair. Right, this expected it to be length of indexes. Okay, so this will be used in the future exercise, which should be this one, I believe. So pairs bootstrap. Okay, pairs bootstrap of what we did just now. We get the literacy and fertility data. So now we're going to do the pairs bootstrap. Use your function to take 1000 bootstrap replicates. X-axis data is illiteracy, y-axis data is fertility. Draw, we're going to call the function. Draw bootstrap pairs linear regression. We're going to take in X and Y. And how many replicates? We're going to take 1000 replicates. X and Y, it says X is going to be illiteracy. So like that. And Y is going to be fertility. Just like that. And we want to print the 95% confidence interval. So we start with 2.5 and 97.5. And that looks good. It allows us to draw the pairs linear, the pairs bootstrap, right? It shows us the pairs bootstrap histogram of probability distributions. Right. Wait, sorry. Did I specify the first argument correctly? No, definitely not. The first argument is for slope. BS slope reps. The second argument is a list, right? From 2.5 to 97.5. Right, I believe that's right. Okay. Awesome. So now it's already 1:51 p.m. We'll just continue with a few more exercises. Can we actually finish this before? No. We still have one more before we go to hypothesis testing. In fact, let's just finish this last exercise and then we will check if there's any final questions on the different platforms like Discord before we close off the session. Thanks again for joining us here and hope you're having a lovely Wednesday afternoon. Generate array of X values for bootstrap lines. Okay, I'm going to plot bootstrap regressions. A nice way to visualize the variability we expect in a linear regression is to plot the line we get from each bootstrap replicate of the line and of the slope and intercept. Do this for the first 100 of your bootstrap replicates on the slope and intercept. Sort as BS slopes and BS intercepts. Okay. Generate an array of X values consisting of 0 and 100. An array, so an array 0 and 100 for the plot of the regression lines. Yes, just like that. And then for I in range, 100 lines. It says do this for 100 lines, so I'm going to do range 100. We're going to plot the regression line of a slope intercept given by the pairs bootstrap replicates. When plotting the regression lines in each iteration of the for loop, recall the regression equation y equals to ax plus b. So this is the ax plus b. Here a will be BS slope reps I plus BS intercept reps I. Okay, we're going to plot that. Looks about right. Line width will be 0.5. What is 0.2? Alpha is 0.2 and color will be red. I'm going to admit that this is one of the more drier exercises, but we're going to just push through it, right? Because you got to take the dry with the tasty. Okay, let's push through. Plot this against that. X values. Plot the data. Make a scatter plot with illiteracy on the x-axis. plt.plot. X-axis is illiteracy. Y-axis is fertility. Marker equals to nothing. It's a dot. And line style equals to none. That's how we do a scatter plot here. And it looks okay. Just run this and submit our answer. Looks okay. Great. Great. I'll give it 1 star. There's a lot of too much jargon. Not enough explanation. Okay, now I think it's one of the more interesting.
When we study linear,
one of the more interesting topics I think in statistics is formulating and simulating a hypothesis. We'll keep this, I guess, for next Wednesday's session. So formulating and simulating the hypothesis is a really interesting topic, I think, and it's a way to statistically say whether some statement is statistically significant, whether something is true or not, and with how much confidence. Right. So if you have any final questions, please put them right into the YouTube chat. I don't really see any questions this time. So if not, then I'll just check on here. AC in the Discord asks, thanks for organizing the session. Is there an index of sessions to DataCamp topics? Has Data Science Toolbox 1 been covered during my previous lesson? Thank you. I have to check this out after the session. Then I will let you know, AC. Thanks for the question. James Pong Sheng Yu is typing something. I'll just wait for this last question. If you have any final things you want to ask, please do it now before we close off the session. Thanks everyone for joining us on this lovely Wednesday afternoon. Thanks for joining me during your lunchtime. I appreciate that your time is valuable. Please continue making progress on AI4I. And if you have any questions, just feel free to hit us up in the Discord. Ask questions in the Discord. It's a great place where you can talk with your fellow learners. Some of them are people who studied computing, some people who studied masters in data science. Some people are just completely new programmers. Most of them are actually completely new programmers, just like most of you. Okay. Don't see any question yet from James. Let's see. Any questions? Any final questions? Any final questions? If not, I think we will just go ahead and close up the session. Let me just give him another 30 seconds to complete this question. Yeah, so anyway, the Discord is a really good place for you to ask questions about whatever you want to know in AI4I. Share resources to learn Python, to learn data science, to get ideas for projects, for your data-related projects, to get ideas to what projects you can use to build up your portfolio. Okay, James Pong just had some feedback. Thanks for the session. No problem, James. Okay, so we're just going to close up the session. And if you have any further questions or particular topics that you want to know about in future sessions, just let me know. Maybe in the Discord would be a great way. And we will do that next time. Thanks again for joining us. And this is Ishan. Have a great day ahead. Bye-bye.